video completing the square, where we're going from standard form to vertex form. So here's an example, and then I'll go ahead and give you the steps how to solve it. So first of all, you always want to divide by your a on both sides. So I divide every term on the right side and even the f of x on this side. So I get x squared plus 4x, plus 2x plus 5 over 2. And it's okay, that's the fraction, it'll work itself out later. Then we go ahead and move the old c to the other side. So we move that old c to the other side. So we get f of x over 2 minus 5 over 2 is equal to x squared plus 2x plus our new c that we're going to find, and we find our new c by taking our b, dividing by 2, and then squaring it. So that's beautiful too. So our b is 2. It's this b right here, this b2, and we're going to divide that by 2, and then we're going to square it, so that's 1. So we're going to add it to this side, and we're going to add it to this side on the left here, but I'm going to add it as 2 over 2, which is still 1, because then I have a common denominator. Now we can add that together. So we get f of x over 2 minus 3 over 2 is equal to x squared plus 2x plus 1. Now the next step is to go ahead and factor the quadratic side. So we'll factor this quadratic side, and so we get x plus 1 times x plus 1, or just x plus 1 and quantity squared. That was the whole point of doing a completing the square, is so we have a perfect trinomial where we can factor it easily. Okay, now we can go ahead and move that old c that we had and move it to the other side. So then we have f of x over 2 is equal to the quantity x plus 1 squared plus 3 over 2. Now we're going to go ahead and get rid of those fractions by multiplying by 2 on both sides. So that means I have to multiply this term by 2 and this term by 2, so both of them. So that's the way that we get rid of those fractions. And now it looks like it's in vertex form, which we talked about on the last video. So that's how you do it, and then here are the steps of how to do it. Divide everything by a, move your c to the other side, find the new c by taking your b and dividing by 2, and then squaring it and add that to both sides, and then factor your quadratic side. It's always going to be x plus your b over 2 quantity squared, and then solve for f of x, or it might be in terms of y instead of f of x. It might just say y equals, so then you'd be solving for y, and you usually do that by moving your old c back over and then multiplying by your a on both sides of the equation. Okay, here are a couple more examples that I'll do real quick. So I'm just completing. I divide by my a, but my a is 1, so that's not going to change anything. So I just move over the old c. Leave a space for the new c. Take my b, divide by 2, and then square it. So that's negative 3 squared. So that equals 9. So I want to add 9 to this side and not add 9 to this side. So I get f of x plus 2 equals x squared minus 6x plus 9. Now I factor the quadratic side, and that is my x plus my b over 2. My b over 2 was 3, so that's why I have a 3 here. Quantity squared equals plus 2 plus f of x. Move the old c over. Here we don't have to divide by a because our a is 1, so that's not going to change anything. So there is our in vertex form. Okay, so now these do say, I didn't do it on the last demo, but these do say, the homework problems do say to go ahead and graph this. So I can graph my vertex right 3 because it's always the opposite, and then down 2. So there's my vertex, and then it has you graph the rest of it. So we graph the rest of it just by picking another number like we practiced before, plugging it in, and seeing what we get. And then we're going to subtract 2 after I square negative 1, so that's 1 minus 2, that's negative 1. And then I can fold that over my axis of symmetry, which is right here. I am, oops, I went 1. It should be, I plugged in 2, so I go over 2 and I go down 1 because it's a negative 1. So I'm over 2 and down 1. And then I fold it over this line. Right, there's axis of symmetry, so it's the same height. So there's the graph. I could have did a little bit better on that, but that's okay. Then it wants to know the axis. That's talking about the axis of symmetry, so that is always x equals, and it's the x value of vertex, which is a positive 3. Then it asks for the domain. The domain is going to be all quadratics are negative infinity to positive infinity. And then our range, since it's facing up, that means it's going to be the y value of our vertex, which is a negative 2. And then it goes up, so it's positive infinity. So that's our range. Okay, and lastly, it asks for where is it increasing and decreasing on our domain. And remember, increasing and decreasing is always reference to the domain, right? So we got to go from negative infinity to positive infinity, but it's increasing from the x value of our vertex. Always, if it's facing up, okay, so I'll jot this down later. But for this example, we're going from positive 3. So positive 3 to infinity. That's where it's increasing. And it does have, I do have an x value of negative 3. And then we're decreasing, it's not constant. And it's decreasing from negative infinity up until 3. And again, it's a bracket. Because here, my graph is, as I go along the x-axis, my graph is going up. So from that 3, even though 3 is kind of down, so my graph is actually something like this, right? And it's going up there, and then it's decreasing from negative infinity this way. It's coming down to that 3 value, right? That x value of 3. Okay, so that's increasing and decreasing. After I do these examples, I'll go ahead and post kind of how you can always do increasing and decreasing. Okay, so here we go. We can divide everything by a, so that's g of x over negative 3 is equal to x squared plus 2/3. This is where it gets complicated a little bit because we have fraction here, minus 1/3. So minus 1/3. Okay, and now we're going to move that old c over. So we're going to add it because it's a negative currently. And now we have x squared plus 2/3 x. Then we're going to add that new c. Running out of room there. So the new c is taking our b, which is 2/3, and dividing that by 2, which is multiplying by a half. So these 2's are going to cancel, and I get 1/3. So I'm going to add 1/3 here and 1/3 here. So on this side, I get g of x divided by negative 3 plus 2/3 equals x squared plus 2/3. Even though this thing looks complicated right here at the end, it's not going to be, or it's still kind of going to be, but when we factor it, we don't need to think it's that complicated because it always factors to x plus your b over 2, and my b over 2 was 1/3. Oops, I did forget something. It is 1/3 here. That is true. Okay, and quantity squared. The only thing that I messed up on was I forgot to take my b over 2 and square it, which is not going to affect this binomial squared. It's still going to be x plus my b over 2, which is 1/3, quantity squared. This 2/3 is not going to be the same. So sorry about that. I can't rewind it or anything. It just continues to go. So I'm not actually adding 1/3 to both sides. Because it's actually going to be this squared, which is 1/9. So I'm actually adding 1/9. Again, this is not going to affect this side because it always factors to x plus b over 2 quantity squared. But I am adding 1/9 to this side. Okay, so that means I need to write a common denominator, so that this would be 3 over 9. Now I can add and get 4 over 9. Okay, so now I can go ahead and we combine those. So now we can go ahead and move that c over to the other side. So let's scroll down here a little bit, get some room. So we have g of x over negative 3. We're going to move this 4/9 to the other side by subtracting. So we're going to subtract 4/9. Okay, now we're going to multiply by negative 3 on both sides. And when I multiply this right side by negative 3, multiply by negative 3, we're going to multiply this binomial and this one. Okay, so we just get g of x is equal to negative 3 with the quantity x plus 1/3 quantity squared. And this negative 3 is going to cancel with this negative 9, and it's going to become a positive. and then we're going to get 4 over 3. And so there is our quadratic equation there. Okay, now to graph it, again we take our vertex, opposite 1/3. So I'm going to go left 1/3. So 1, 2, 3. So this would be 1, and so 1/3 would be right here. And then 4/3, I'm going to go up 4/3, okay? So 1, 2, 3, 4, because this is 1. So this would be 4/3, because I'm counting by 3s here. So it is over 1/3 to the left and up 4/3, so right here. Alright, so there's my vertex, and now I can plug another point. So this might be a little bit hard, but what I want to do is I want to choose an x that I can complete this as a whole number. So what plus 1/3 would equal a whole number, like 1? So that'd be 2/3. So if I plug in 2/3 and I add 1/3, then I get a whole number 1. So my x is going to be 2/3 that I'm choosing. And then so I add that, I get 1. 1 squared is still 1. 1 times -3 is -3. So I have -3 plus 4/3, so I need a common denominator. That'd be -9 thirds. -9 thirds. So -9 thirds plus 4/3 is 5/3, right? A -5/3, excuse me. So my 2/3 is my x, and -5/3 is my y. So it looks a little complicated. You got to think about this a little bit more. You could still plug in a number that you wanted to for x, but it's just a little more complicated to find. But I'm confident that you can find it. So I'm going to go over 2/3 to the right now. So 1, 2, 3 would be a whole. So I'm going to go over 2/3 right here, and then I'm going to go down 5/3. 1, 2, 3, 4, 5. So that'd be a whole. -1. This would be negative, actually. So this would be over 2/3 and down 5/3. So right here, and then I can flip it over. This is 1, 2, 3 away from the axis of symmetry, because my axis of symmetry is x equals -1/3. So there's your axis of symmetry, or your axis, which the books actually ask you to find. So x equals 1/3 there. I could probably write that better. Okay, then I fold it over, so it's 1, 2, 3 away, so 1, 2, 3 away, same height, and now I can graph, and I can kind of check it. I mean, I could check it all the way by plugging in these x values and making sure they're the same, but I know that the -3 does make it face down, so I know that negative at least is right, so I know it should face down, so I know I probably have a little bit correct, and then you can check in the back of the book when you do your homework to make sure you have the right graph. Okay, now we're doing increasing and decreasing. Well, the domain, I guess, first. Domain, again, from -infinity to +infinity, always with quadratics. The range, since it's facing down, we're going to go from -infinity up until that y value of the vertex, which is 1, 2, 3, 4, 4/3, +4/3. And it does hit 4/3. Okay, then increasing and decreasing. Increasing, it goes up. We read it from left to right, right? So it's going up here. Let me use a different color. It's going up right here. It's going up right here. So that's increasing. And it's increasing from -infinity on our x's up until this x value, which is 1/3, a -1/3. And then where is it decreasing? It's decreasing, goes from that -1/3 up into +infinity. These ones I kind of don't have to think about as much, because with all quadratics, if it's facing up, you're increasing. Okay, so if it's facing up, it's always going to be increasing from the, is the bracket, x value of vertex of your vertex, so x value of your vertex, to +infinity. And so what that has to mean is, because our domain goes from -infinity to infinity, that I have to complete. I already have +infinity, so that means I got to go left to -infinity. So my decreasing has to go from -infinity up until that x value of the vertex. Right? Because if I join these together with the union, it will be my full domain. Ooh, that looks good. X value of vertex. Being sarcastic, that doesn't look nice. X value of your vertex. Okay, and then if it faces down, they just flop there. They switch. So you're decreasing. Your decreasing would be from your x value. Sloppy. Of vertex to positive infinity, and then your increasing would be from negative infinity to the x value of vertex, because increasing and decreasing is always on your domain. Okay, so that's it for the video and doing examples. Here's your homework for those kind of type of examples on page 293, numbers 21 and 23. And you're also asked to graph it, and you're asked to find your domain, your range, where is it increasing, where is it decreasing, and your axis of symmetry, along with your vertex. So go ahead and do those. If you have trouble, come back to this video and watch me do the problems right now. Okay, so here's number 21, f of x equals x squared minus 10x plus 21, where we do not have to worry about dividing by a because our a is 1. So we just move our old c over. Okay, and then we're going to find our new c by taking our negative b, or sorry, just our b, which is negative 10, and dividing it by 2, and then squaring it. So don't forget to square it like I did in the other example, right? So square it, so that'd be 25. So we're going to add 25 to this side, and we're going to add 25 to this side. So that's f of x plus 4 is equal to x squared minus 10x plus 25. Now we go ahead and do the factor, the quadratic side, and that's always x plus your b over 2. Well, my b over 2 is negative 5, right? So it's x minus 5, quantity squared, equals f of x plus 4. Now we can move over that old c to the other side by subtracting it. So there we have it written in vertex form, so now we can go ahead and graph it. We can label our vertex, which is opposite of the inside, which is 5, and the regular on the outside. So there's our vertex. So there's our vertex. Axis of symmetry is always the x equals the x value of your vertex. So it has to have that x equals there. Now we can go ahead and name the domain. We know the domain of all quadratics is from negative infinity to positive infinity. So you notice I haven't even graphed it yet, and I can figure out what this stuff is without even have to graph. And my range, since it is positive here, it's a positive in front, that means that it is facing up. So I know my range is from my y value of the vertex to positive infinity. And then I know increasing, since it's facing up, is going to be from my x value of my vertex to positive infinity. And then I know decreasing is from negative infinity up until that x value of my vertex. So there, I've done all the steps without even having to graph, right? So now I can come back and graph. I'm at 5, 4, and now I know I can just plug in another point. I always want to do close to this value 5. So I want to do 4, right? Because 4 minus 5 is negative 1. Negative 1 squared is still 1. 1 plus 4 is 5. So it's just going to be up 1 here. And then I flip it over my axis of symmetry, which is x equals 5. And it's going to have the same height, so I go over 1. Now I can graph my parabola. All done. Okay, so now I'll go ahead and do number 23. Oops, 23. Okay, so here's number 23. So we notice that to begin with, we have an a. Yeah, we have an a, right? So we need to divide everything by a, left side and right side by a. Then we need to move that old c to the other side, which is now going to be a positive 8, so we need to subtract it from both sides. And so then we get x squared plus 6x. And then we're going to add our new c on this side. So that's taking our b, our new b right here, which is 6, and dividing that by 2, and then squaring it. So we get 3 squared, which is 9. So we're going to add 9 here, and we're going to add 9 here. And then after we're done doing this, we can go ahead and factor this quadratic, plus 9. And that's always going to factor to your x plus your b over 2, which is 3, quantity squared. That's a positive one. So, and now we can go ahead and move over this old c to this side, so we can subtract on both sides, so then we just get f of x over negative 2 is equal to x plus 3 quantity squared minus 1. Now we can go ahead and multiply both sides by 2, or negative 2. So this whole entire side by negative 2, so that means I multiply this quantity that's being squared here and the negative 1, so that makes a positive 2. And then this just becomes f of x because those fractions cancel. So there's our, in vertex form. Now we can go ahead and identify the vertex. Our vertex is opposite of the inside and regular on the outside. Okay, and then vertex, so now we can do our domain, or actually access the symmetry. Let's go ahead and do that first. So x equals negative 3, because it's always x equals the x value of your vertex. Now we can do domain, which we know is all quadratics are negative infinity to positive infinity, and our range is, since it is negative, that means facing down, so that means it's going to go from negative infinity up until that y value of our vertex, which is 2. Bracket, because it does hit 2. And then increasing and decreasing, again, since it's facing down, that means it's increasing from negative infinity up until that x value of your vertex, which is negative 3. And then it's decreasing. So I need to complete this from negative infinity to positive infinity, right? The increasing and decreasing is your domain. So we're going from negative infinity to negative 3, so now we have to go from negative 3 to positive infinity. And now we can go ahead and graph it. Or you could have graphed it first, I don't really care. So we go over left 3 because it's positive 3 on the inside, so we go always opposite, and then it's up 2. So there's our vertex. Now we can plug in another number. Something close to 3, I would do negative 2. Because that equals 1, and then 1 squared is still 1. And then we're going to times that by 3, right? And then we're going to add 2 at the end after we do that. So 3 times 1 is 3, 3 plus 2 is 5. So we're going to go at negative 2, we're going to go up 5. So 3, 4, 5. So over 2, up 5. And then we use the axis of symmetry. We fold it over that line. So I'm 1 away from the axis there, so I'm going to go 1 this way and complete same height, and then complete my U. So there's the graph for that. So there is 21 and 23. There it is.